Before we dive into working with quadratic functions, we want to start off by discussing the characteristics of parabolas. A parabola is this U-shaped curve that we get whenever we graph a quadratic function of the form f of x is equal to ax squared plus bx plus c. Quadratic functions always have a degree of 2, since the largest power that we see is x raised to the second power. The graph that we have on the right is also a parabola, also the graph of a quadratic function. We'll call this g of x is equal to ax squared plus bx plus c. Since it's a quadratic function, it also has a degree 2, but we can see the behavior of these two functions seem opposite of each other. One is opening up and one is opening down. That's controlled by the value a in the quadratic function. Since f of x is opening up, that tells us that the value a in that function must be greater than 0. And since g of x is opening down, that tells us that the value a in this function must be negative, or less than 0. So that value for a controls whether our parabola opens up or opens down. Every parabola has a vertex. For f of x, we see this occurs at the point -2, -3. And for g of x, it occurs at the point 2, 3. So the vertex is that turning point in the curve, either the peak of that mountain or the base of that valley, depending on which way our function is curving. But it's that point where our function changes direction. In the case of our function f of x, we can classify this vertex as an absolute minimum. Since that point -2, -3 is the smallest function value that function will ever take on. And for g of x, our vertex of 2, 3 can be classified as an absolute maximum. Since that point includes the highest function value, the largest function value that our function will hit. Parabolas can have one or more intercepts, which would be of the form x, 0. That would represent an x-intercept where we have some value for x, but that y value is going to be 0. Or we could have a y-intercept, which would be a point of the form 0, y. So we have some y value where we intersect the y-axis, but our x variable is equal to 0. The two curves that we have, or the two functions that we have graphed here, each have two x-intercepts, so those points where we intersect the x-axis, and one y-intercept, which is the point where we intersect the y-axis. Depending on where a function exists on the coordinate plane, again, we can have differing numbers of intercepts. The next concept that we want to talk about is the end behavior of these functions, which deals with what's happening to our function value as x becomes very, very large. So as x approaches positive infinity, and what's happening to our function value as x gets very, very small, so approaching negative infinity. To understand this behavior, we literally just want to start at the vertex and trace along our curve first in the positive x direction. So as x is getting larger and larger, we can see that our function value is continuing to increase to positive infinity. If we go back to that vertex and now trace in the negative x direction, so as x gets smaller and smaller, we see that our function is still headed in that same direction towards positive infinity. So we can go back to our end behavior statements and say that as x approaches infinity, f of x is approaching infinity, and as x approaches negative infinity, f of x is approaching positive infinity. So at both ends, the extreme values for x, our function is headed in the same direction. We can repeat that process for g of x. We'll start off at the vertex and trace in the positive x direction. So now we see that as x is getting larger, our function value is getting smaller and smaller. And as we start at the vertex and trace along in the negative x direction, our function value is also getting smaller and smaller. So as x is approaching positive infinity, g of x is approaching negative infinity, and as x is approaching negative infinity, g of x is again approaching negative infinity. Notice that our values are the same in each direction for a parabola. So regardless of the direction x is headed, the function value is headed to the same result. And again, whether that's positive or negative infinity is dictated by our value for a, because when a is positive, our curve opens up, so we're headed to positive infinity. When a is less than 0, negative, then our curve opens down, and our function value is headed to negative infinity in both directions. For a quadratic function, we can also identify the domain and range. The domain for a quadratic function, or its graph, which is a parabola, will always be negative infinity to infinity. Because there are no holes or breaks in that graph, there are no values that we could plug into a quadratic function that would break it. We're not dividing by 0 anywhere. We're not taking the square root of negative numbers. So we can throw any x value at that we want. All values would be in the domain, but our range will have a restriction. To identify that, we'll erase what we already drew here a little bit. Range relates to our y coordinates. So what we want to do is look at that minimum y value that we could hit of -3 and see that we would only come into contact with y values that are larger than that. So our y value would never dip below -3 for our function f of x. So our range would be -3 to infinity. We always put a rounded bracket around infinity, and we would put a square bracket around the -3 to indicate that that point is included as part of our range. Then for g of x, we would look at the same idea. In this case, we have a maximum y value of 3, and our function is only going to come into contact with y coordinates smaller than 3. So our range in this case would be from negative infinity all the way up to a maximum value of 3, again with a closed bracket to indicate 3 is included as part of that range. And then something to notice here is that the values we have as the endpoints for our range, the non-infinity endpoint, each of those is the y coordinate of the vertex. So once we know the vertex, we know the bounded end of our range, then we just need to determine whether the graph is opening up or down to know which side is headed to either positive or negative infinity.